I'm Drew Winter with WardsAuto, and I guarantee in the next few minutes, you're going to learn a bunch of cool things that you didn't know before. We've got some great panelists today, and I'd like them to join me up here now, and I'll introduce them as they walk up. First off, Hugh Blaxell, General Manager and Head of Engineering Services at Mala Powertrain, North America. Hugh, come on up. Craig Reinecker, Vice President of Driveline Product Engineering at AAM, or American Axle. Come on up. Carl Severston, Vice President of Engineering and CTO, Vehicle Group at Eaton. Carl? And Jorg Trampler, Head of Engineering Center, North America Car Powertrain Technology at ZF. Jorg. I've covered automotive suppliers for the past 30 years, and I think the analyst community, Wall Street, and sometimes even their customers have not understood them very well. As we move into the era of electrification and autonomy, I think the situation hasn't improved. In fact, I'm amazed at how many so-called experts think auto suppliers are sitting on their hands and watching the world go by as the world changes. So, as a way of introducing each panelist, I'm going to ask each one to take a minute or two to talk about what they are historically known for and what they're working on today and for the future. So, let's start with Hugh Blaxell at Mala. Hugh, Mala makes pistons, right? So what else are you up to besides pistons?
Yeah, everyone says that. Yeah, you guys make pistons, yeah. There's been a lot of change in Mala over the last, I guess, 10, 15, even 20 years. There's been a huge acquisition strategy that Mala's followed, and I think many of you will be aware of that. Even in the early days, we purchased 10X to get involved in more the external side of the cylinder block, intake systems, carbon canisters, that sort of thing. And it's grown from there, the more acquisitions. I joined as part of Cosworth Technologies acquisition from the UK, and that brought a systems level expertise. Other acquisitions have been, certainly the biggest one has been Bear, which is now operating out of our Troy office. And that was a huge investment and brings along thermal systems to our capabilities. More recently, I think we've grown into the electrification market. We've bought 2 companies out of Europe that enable us to provide electric machines and power electronics. So you can see we've sort of had this sort of evolutionary growth from, I guess, the core component of an engine with a piston through to all of the external parts and then into the vehicle and then cooling systems and then through to electrification. So there's been quite a lot of activity, and we've demonstrated that in the marketplace as well. So back in the early days, we've demonstrated downsizing with downsizing vehicles, numerous hybrids, range extenders, parallel hybrids, and then more recently a dual mode hybrid. We've done numerous, I guess, more diverse activities. We've got involved in fuel cells, waste heat recovery, full electric vehicles. I think Frankfurt last year we introduced the Meet vehicle, which is a small city vehicle. And actually around the same time got involved in producing an electric bicycle. So lots of activity. We do maintain a sort of I would say a split strategy where we want to continue to support the powertrain, the IC engine activities, as well as supporting the new electrification area. And that's a challenge for us, of course. But an example of some of the technologies we've introduced to improve the efficiency of IC engines is the Mala jet ignition system. So we're working in both areas to try and develop capability and improve what we can do, offer to OEMs.
Okay, we'll talk a little bit of that later. So, Craig, at AAM, everybody knows American Axle makes a zillion axles for GM pickups. but they probably don't know you help make electric Jaguars, right?
Yeah, that's right. Our company was founded 25 years ago. We had our 25th anniversary here recently. And as the name describes, American Axle, we were formed to produce truck and SUV axles. General Motors is our first customer, remains a very important customer to this day. And the truck axle business is a very good business to this day. We've diversified with a number of other customers, but we see that market continuing to be strong and stable and healthy for quite some time. So it's a very important part of our business and will remain so. But we are diversifying. 3 years ago, we made an acquisition of Meadowline Performance Group, and that brought in some automatic transmission component business, and also an entire business of engine vibration control systems. As you heard the discussion about the trend to downsize boosted engines, 3-cylinder engines, cylinder deactivation, P0 hybridization, every one of those things makes engine vibrations worse. So there's a strong need for more and more vibration control content in the engines, and that's now part of our business. And now 10 years ago, we formed a joint venture with Saab to develop electrified products. And that's probably something that everyone may not have known. And the first market development there is the Jaguar I-Pace. So show of hands, how many people in the room knew that American Axle provides the electric drives for the Jaguar I-Pace? Okay, my table over there, there we go. All right. So I think that's one of the best kept secrets in the industry. It's a very challenging product to get luxury, NVH, and performance out of an electric drive is a very difficult challenge. And American Axle is able to leverage all of their gear capability, but then also integrate the electric drive capability. And we're then moving on from there. So we've announced that we have a next major customer in Europe for an electric drive that'll be coming out yet this year, and we've got 2 more lined up in China, and we just continue to see that grow. And our innovation in that area is to attack all of it. We want to attack all of that. We want to develop motors and power electronics and gear drives, and not just be the gear train, the gear people in electrification. So we see a good, strong core business in truck axles that'll continue for a long time, and then we'll be are preparing to move into the world of electrification as that grows.
Okay, great. Our next speaker is Carl Sievertson. Did I butcher that or not?
Sievertson, that's right.
Oh, okay. So now, Carl Eaton makes a million engine valves a day. Do you just make engine valves now and twiddle your thumbs, or are you investing in electrification and all that stuff?
We banned thumb twiddling from our corporate culture a few years back, but we do make a million engine valves a day, and we love engine valves, and we love internal combustion engines, and we do a lot more in that space as well. And over the past 15 years, we've really focused more and more on how to squeeze additional efficiency and performance and drivability from that platform. So in addition to having ever more sophisticated engine valves that work in harsh environments and better thermal manage, we've moved into advanced variable valve actuation, historically cylinder deactivation, those kind of things, hydraulically actuated, and those systems now are becoming more modular, more flexible, electrically actuated, electronically actuated. So again, all more or additional technologies to improve the breathing and drive that efficiency. From our boosting business, a lot of people know Eaton through high-performance supercharging, and we still do that today. We still love to breathe excitement into today's high-powered engines. But that technology, we call it our TVS pump, is really a very, very efficient metered air pump that we're seeing have new life and new applications anywhere from advanced combustion, not just pumping air, but blending air and inert exhaust gases to enable new combustion strategies and new efficiency. Even in the commercial diesel space, improving thermal efficiency and catalyst efficiency in terms of heating and managing the catalyst temperatures. So we see really a lot of application there. And even further when we talk about fuel cells, although the adoption rate on the pass car side seems to be looking for its traction. I think on the commercial vehicle side, we're gonna see a little bit more movement in that time period. And even there, that air pump, if you will, has some interesting throttling and value characteristics in feeding air into a fuel cell. So on the internal combustion front, we think there's a lot of work to do, and there's a lot of things that we can do to continue to support our customers. However, we are heavily advancing in the electrification space as well, and that's really not a new space for Eaton. Eaton is really at its heart a power management company, and the electrical sector of our company is really the largest sector, dealing with very, very high voltages safely, higher voltages than you'd ever see in a passenger car vehicle, unless you're driving maybe a 1985 DeLorean and trying to get back to the future. But in terms of that kind of technology coming into the vehicle space, that's where our focus has been in our e-mobility sector for the past few years now. And we have very high efficiency power conversion, inverters and converters. We're managing the power safely with fusing and very rapid and safe power disconnects for that high voltage, and even developing next-gen systems that are electronically controlled and resettable high voltage power protection in that space. So a ton of things going on in both the electrification space and the internal combustion space at Eaton, and we're happy to be in it.
Great. So finally, because he's last in our alphabetical order, we have Jorg Trampler at ZF. Jorg, everyone knows ZF makes terrific transmissions, but have you ever thought about doing something crazy like, integrating modular electric motors into the 8-speed step transmissions?
Well, being a German company, we don't do crazy, and we don't make jokes, so that's the thing. No, I think we're best known for our 8-speed transmission mated to the classical powertrains, 4-cylinder, 6-cylinder, 8 or 12-cylinder internal combustion engines. However, we've been in electrification since I think about 2007 when we introduced a 42 volt, I don't know if anybody remembers, 42 volt, crankshaft starter generator. And since then, we've constantly increased our development activities in electrification. And so we recently, a few years ago, ZF created a dedicated division dedicated to e-mobility. And that's basically where our electrical components are being developed. So that's where we develop electric motors, inverters, power electronics, shifters, and these parts are, and also the axle drive. I almost forgot the EVD axle drive. I'm sorry, guys. So, and we're successful with that division. I mean, we started series production last year with our EVD drive supplying to Daimler for the EQC model. But also, and that's where the modularity comes in, I mean, the electric components we need in our hybrid transmissions are being developed in that division. So we can basically share our development know-how and spread it over a much larger volume base as compared to just using it in electric vehicle drives. So we've had our 8-speed transmission as a P2 hybrid in the market for several years and gained some experience with that. We're working on our next generation, which is the 4th generation 8-speed transmission, and we will offer even more modularity and we will focus much more in integration, because what we see is one of the key challenges, and let's call it e-mobility / electrification, is system cost. So that's what we want to tackle, and our next generation will be a much more modular approach. And using the same base transmission, we will be able to offer a conventional transmission, non-electrified, a 48 volt mild hybrid, and a high voltage plug-in hybrid version. And also in terms of integration, we will have an integrated power electronics in the transmission in order to save cost, but also save installation space and save on the orange cables in the vehicle. So, I mean, coming back from the company that used to do only transmissions, we know We have to be flexible because volumes in the future are uncertain. Unless someone has some certainty, let's talk about it later, we're interested. We have to be flexible because our customers want to be flexible in terms of what kind of powertrain configuration is needed in which region at which volume.
Okay, that's a good segue because sort of the next segment we're going to go into is, we all know hundreds of new battery electric vehicles are coming into the marketplace in the next couple of years. Many people might think every vehicle sold by 2030 will be pure electric. But I think as we just heard from Aaron Sunday explaining this morning, realistic forecasters say something like 80% or more of all vehicles will still have internal combustion engines by 2030. There will be a lot of hybrids, that's for sure. But still, it's a lot of engines. How do suppliers create product portfolios that are flexible enough to accommodate whatever the future brings without going broke? It sounds like Jorg and ZF kind of, outlined a bit of a plan. But Carl, is it possible to repurpose some of Eaton's components for new applications?
Yeah, absolutely. So, from an Eaton perspective, I mentioned that we're kind of power management. So moving between mechanical and electrical power is just kind of what we do. So we understand how to balance that. Like ZF, we did set up a separate organizational structure focused on electric powertrain, and to have the focus and energy and maybe reduce some bureaucracy and move some speed on the EV front. So we have separate entities managing those spaces, but we're able to shift between the two, throttle up or throttle down between those two spaces as we see maturity adoption, the maturity of adoption kind of solidify, or the regulatory landscape hopefully become a little clearer. So we certainly have that flexibility. And matter of fact, in the same year that we're introducing brand new inverter technology on the EV front, we're launching and helping our customers launch brand new advanced combustion technology on the internal combustion front. But in terms of finding new spaces for our existing technology, I mentioned the TVS supercharger. It really has now wider application, not just in performance and horsepower, but in fuel economy, metering air, really managing the chemistry of what goes into the cylinder to optimize that advanced combustion, even into that HCCI front. And then, again, more recently, we're already selling that device into the fuel cell market as a really accurate fuel metering device for the air handling side of the fuel cell. And for us, the fuel cell, it's almost, for us, it's like an internal combustion engine. There's still a throttling and air handling side of the system, and then there's a fuel and fuel metering side of the system. And we do both. So you know about our valve train and air handling side on the internal combustion engine, but we also manage the fuel vapor on the gasoline side of the business as well. And there's challenges in fuel vapor management for hybridization, where you're not able to pull off the charcoal canister and consume those vapors, and you really have to contain and pressurize the tank and contain the vapors in the fuel tank when the internal combustion engine isn't going to run very often. So we have a lot of technology around electrifying and electronic controls around fuel vapor management. A lot of that, again, that know-how, that technology about metering, sealing, measuring, or so forth, applies to fuel cells and other technologies. And lastly, we're taking a lot of our advanced valve train technology and moving that into the commercial vehicle space, into the commercial diesel space. So valve train technology that in a gasoline engine was all about fuel economy or pumping losses, in a commercial diesel engine might be about keeping the catalyst warm or hot, to keep the efficiency level and NOx reduction where it needs to be. So lots of opportunity for this technology to help across that propulsion spectrum.
I think you've got some components and things that can be transferable too as well, right?
Very much so. I think the cooling systems, is the most obvious. But that grows beyond that. If you look at maybe some of the developments we've done recently with the Marler modular hybrid powertrain, that was is a demonstration of all of the technologies we can bring from the cooling system to a dedicated hybrid engine, so really optimized to suit a dual mode hybrid. And a gearbox, so I didn't mention earlier, but we have a transmission capability that will enable us to actually add that into the portfolio, plus all the electric machines that I talked about that we can contribute. So that combined sort of wide portfolio is something that we can bring to the table. And I'd add on top of that the system level engineering that we can support with, and I think it's an area that we maybe could be used more with the ability to design complete systems, complete powertrain propulsion systems as a solution. So yeah, I think we can bring a lot to the market. Marler's got a very diverse product portfolio. So to your point earlier, it is a challenge to choose where you invest your money, and something that I would say our investment has really reflected that of OEMs as well. You've seen what OEMs do. We're doing the same sort of thing, trying to accelerate our investment in electrification, and maybe not reduce, but just tread water on our IC engine activities in most areas. But we'll see that change over time as the market starts to pull a little bit more in probably both areas as it settles down.
Now, we've discussed this at Wards a number of times, is that as, again, OEMs invest more and more into electrification and whatnot, would it be possible for some suppliers maybe to come in and take over some of the ICE projects that automakers would like to move away from some? And we've gotten some interesting answers. I'd like to ask this group. I mean, I think Hugh, maybe you've got something to say in this area. You wouldn't mind doing that?
I remember when Marler first bought Cosworth Technology, and we were sitting with the CEO at the time and said, "Is your plan to make engines?" And he said, "Well, steady on. Maybe that will upset our customers, because most of our customers actually make the engines." So that was maybe a little bit aggressive. But you can see we've demonstrated a capability in being able to produce at least demonstration and concept engines. We've got teams that produce and put engines into production. So you can put all those together, plus our product portfolio, and say, Marler is in a good place to be able to do that. It's really where the pull's going to come from, whether the market is interested. We see some pull in that area from Asia, and there could be some opportunities for us to get involved in that area. Maybe more of the mainstream OEMs in this room now are probably more capable of doing that themselves, but we would certainly like to be involved in more of a system level approach, for sure, yeah.
How do the rest of you feel about that? Is that of interest to any of you guys to actually do a whole engine? No?
Well, a whole engine might be a stretch. We'll see. We do see, Drew, a lot of customers already combining efforts in terms of the sharing the costs and gaining the scale of developing and maturing and keeping them current, those ubiquitous four-cylinder boosted engines, et cetera. So we see that on the customer front, and we think that provides certain opportunities. From an Eaton standpoint, we have and do make complete cylinder head assemblies, the whole top end of the engine. So we're willing and able to do those kind of things, and we'll see. I think you said the market pull. We'll see where the customers want us to be.
Okay. So even though change in the industry, may not occur as fast as some are predicting, there is a lot of change coming. So I think we've seen so much change lately in the industry. Are we going to even be able to recognize what your companies or the industry looks like in 5 or 10 years? I mean, you just mentioned there'll be a lot more partnerships and things, and so what? Can you maybe each talk a little bit about how your company or what your thoughts are? Are we going to be able to recognize any of these names and companies in the future?
I'll make a comment on that one. I think as you look towards electrification, and what's very interesting to me and to all of us is the competitive set will be a completely different competitive set than it is today, because basically everyone is chasing after that same business, whether you're starting from the engine side, you're starting from the gearbox side, you're starting from power electronics or electric motors. Many of us are trying to integrate and sell that total system, which means the competitive set now could be people with motor background, people with gearbox background, people with power electronics background, and that supply base is very different. It's going to be a very different set, and of course that market is only going to be so big. So there's going to have to be some sort of shakeout where some are going to continue on in that electric space, and some of them are going to have to do something else, because there's only going to be so many electric drives to go after. So I think there'll be a change there, as well as the fact that we will be competing with a lot of our own OE customers that may want to look to bring some of this stuff in-house. So I think that landscape is going to be a bit different.
Okay. Now here's another key question. Today engines are the heart and soul of many vehicles. They're considered core technologies. How can automakers continue to create brand identities and differentiation with EV propulsion systems? I mean, Jorg, I don't think it's a secret that ZF makes a new 2-speed transmission for the Porsche Taycan. Craig, we've talked about Jaguar I-Pace, and I've driven that, and it's just scary fast. So these are two exciting vehicles to drive. Is it all about speed and acceleration, or are there other aspects to creating excitement with EV powertrains?
So I have to correct you first. So we don't do the 2-speed transmission for the Taycan, but
excuse me.
But we have presented, and we're developing a 2-speed electric drive axle, which is not in production yet. However,
okay, that's right.
But still a cool car. So
yeah, right. Okay.
Before going there, just 2 sentences regarding the change of the industry, because that's the exciting part, at least for those people who are not in the industry, the exciting part. I think that change is mainly driven by 2 trends, and that's the electrification and that's the automated driving. So we're talking about electrification here, but ZF is active in both areas and investing huge amount of money into both areas. And we've seen that in the company, that products that do not fall into any of these lines have to fight much harder for funding. So personally, on the powertrain side, we've seen how we went through some cycles in the company. So for years, we were the cool 8-speed guys with the glamorous products and high volumes. And then all of a sudden, a few years ago, we became legacy products. And then we became old products. But I see that's changing now again. So that's good. I think what that reflects is also, it seems like the market is coming back to down to earth, a little bit more realistic, that the hype of tomorrow we will all be driving electric vehicles. Oh no, we will not be driving, we will all be driven in electric vehicles. I think it's becoming more realistic. However, our company is undergoing a big change here, and we're going towards the electrification. Now, coming to the electric vehicles, sorry about that excursion, but I think it's subjective. Let me go back a little bit in time. So when I grew up, the Porsche 911 Turbo, that was the coolest thing ever, and that's the only vehicle I remember from that time who had this turbo badge on it, and it was I didn't even know what a turbocharger was at that time, but it was just cool. Now, when we look at electrification, if we wanted to sell turbochargers today, just on paper, I mean, who of the vehicle buyers think, oh, this is a cool thing, I have a turbocharger in my vehicle? But once they start driving it and they see, well, this comes with a certain torque characteristic, you have high torque at low RPM already, some of them probably don't know it's the turbocharger, but they start liking it. And that's what I think is the electric vehicle thing. On paper, it is expensive, it causes range anxiety, which seems to be one of the key obstacles right now. But once you're in the vehicle, you start appreciating things. And acceleration, yes, it's a cool thing, and there's the Model S, and that out accelerates the SRT Hellcat. I don't know how often times in a row, but that's a different story. But then the question is, how often do you use that? So I personally, what I like much better is the instant torque you get. And isn't that actually what powertrain engineers are looking for, to get a very, very direct connection between your right foot and what the vehicle does? And that's what you have in the electric vehicle. And then there is the lack of engine noise. Others will say there's a lack of engine sound. Okay, I agree, there are different opinions out there. What I want to say is we have to create some kind of excitement. Make electric vehicles exciting beyond what they are on paper, like, oh, this is electric and you don't create any local emissions. That's good and that's important, but I don't know that makes vehicles exciting enough.
Is it possible to make off-road vehicles exciting with electrification?
I think we probably have to ask our colleagues from FCA here. I mean, they introduced the Wrangler plug-in hybrid last week at CES, and I think it will be, I haven't driven it, so it's not available yet, but I think it will be a cool vehicle.
Anybody else want to weigh in on it?
Comment on that. If you have 4 electric motors per wheel and you're driving off-road, you can do a lot of wonderful things with that. Tank turns and rock crawling. And so I think the application of electric drive to extreme off-roads is a wonderful fit. Range anxiety may not be as much. You can go off-roading all day and still not go very many miles. So I think there's good opportunity there.
Yeah, I think I'd agree with that. I think there's plenty of opportunity, and it does open up some sort of exciting off-road capability. So it'd be interesting to see how that evolves. I do think, though, maybe pragmatically, if you're using one of those vehicles for extended journeys and so forth, I think I'd like an IC engine so I can guarantee I've got a fuel source wherever I am. It's a lot easier to get hold of, so maybe I'm a little bit conservative on that front. Another point worth mentioning, and I did ask a few friends on this question, is, what do you think about this? And the general feedback was, well, what about the people who have this in 10 years' time? What are they going to do with that vehicle? They're going to want to tinker with it. They're going to be doing various things. We need to give the buyer and the end user the opportunity to work on the car, upgrade the car, do things to the car. So as long as there's that capability, which I think is perfectly capable with 48-volt systems, I think I've got a few nerves when we talk about high-voltage systems.
So we touched on hydrogen fuel cells a little earlier. We've seen a lot more interest in fuel cells recently, and especially related to things like buses for China and Class 8 trucks. And we the Hyundai Nexo was on our 10 best list last year, and I've followed hydrogen for decades now, and just am amazed at how the technology is improving. What's your guys' feeling as to how much of a business case, how attractive that looks going forward?
Yeah, I'll take a stab at it. I think we saw in the pass car adoption, there's still a lot of ground to be made on the infrastructure and so forth. But on the commercial vehicle front, I think there's a little bit more of a initial value proposition in the speed of refueling, the energy density, the range, and those kind of things. But I think for me it really ties back to eventually the end game of really decarbonizing our fuel ecosystem and what role hydrogen can play in that, in terms of a buffer transportable fuel that leads to the end game we're all looking for. And I think the fuel cell stack and the fuel cell systems now are, like you said, evolved and performing at a level that technology is there. Executing, in the vehicle is we're there. And I think even from a cost perspective, we're probably there. It really comes down to the different ways and costs that you can produce the hydrogen, and making sure that whole infrastructure and production side of it kind of catches up. But I think that you see the more interest now seems to be in the early applications on the commercial vehicle side.
I think from Marla's perspective, there's a definite interest. We've got a team of people working globally in fuel cells, and we're looking at how we can apply our existing products, cooling systems, pumps, valves, and so forth, to support the fuel cell stack itself. I think it's well known that we're partnering with Nikola in the development of their heavy-duty truck, and we're working closely with them in the cooling systems area. So there's a lot of things that we can support with, and we do see it as a technology that's going to be most I guess, prevalent in the truck and bus market, and that's an area that we're really focusing in. So, yeah, we're very interested in it, and it's something we'd like to support going forward.
Okay. Last question. As we access and ease of charging are keys to the success of EVs, are there opportunities for suppliers such as yourselves to exploit this opportunity? I mean, now, Craig, you have, if you look at your background, I think you've got quite a bit in electrification and some interesting background. Is this, is that a whole separate sort of supply chain in terms of the recharging efforts and things like that, or could that be expanded into any one of your portfolio?
Well, I think as I've actually used these electric vehicles, the reality of range anxiety really can sink in. And I'll tell you a simple story. We have the I-Pace, so we've got a number of I-Paces at work. And a team and I, we set out to drive to University of Wisconsin one day. We thought this is a perfect chance to take the I-Pace, and we'll use the Electrify America charging stations along the way. There were 7 charging stations between Detroit and Madison, Wisconsin. And we thought, well, we've got 220 miles worth of range on the vehicle. This should be no problem, only 140 miles worth of range between stations. We ended up driving my Yukon. And it's because when you actually did the math and realized, well, I can't sit at that recharging station in Kalamazoo for 4 hours. I can't sit there. I can only maybe afford to stay there for a short period of time. So we realize we need far more infrastructure than we have today, and we've got to get the charging times drastically down, on the order where the 800-volt Porsche is now. So I think we're going to have to see that change. So I think our role is not necessarily to put in the infrastructure, but to continue to develop the power electronics and the batteries so that we can charge quickly so customers aren't waiting for 4 hours at a charging station. And I think that challenge is still very large. Electrify America's got thousands of stations across the country, and they need 10 times that many to really be able to have large numbers of people going long distances with electrification.
I think from our side, if I can jump in, one of the activities we've been doing, and it's been rolled out at Stuttgart Airport. It's called Charge Big, and it's a different charging system that maybe isn't designed to charge as quickly as possible. It's designed to charge as much as you need. So it is focused on, say, for example, a company parking lot, airports and all that sort of thing. So yes, we've got involved in that sort of area as well to see whether there's any market for us. It's early days, but it's nice to at least investigate whether we can get involved from a market perspective.
From an Eaton perspective, we have power management, in the grid itself, in your homes, and in the vehicles. So everything from bidirectional onboard charging, what that means in terms of managing the overall, let's say, microgrid of a home, or balance charging in municipalities. We want to be part of that whole solution. So we think that bringing the right infrastructure at the right charging speed, at the right cost, and doing it safely, that whole ecosystem is an area that we have deep interest in.
Jorg, you wanted to say something?
Yeah, I'm with Craig on this side here. So I think there are other companies out there, like the utilities companies, who have a big interest in selling electricity. They are the oil companies who have to defend the business, and they have a network of gas stations across the country. From our point of view, so therefore, since I mentioned, we are investing in e-mobility, we're investing in automated driving, so we don't really have the funds and also on the side build up a network on that. Our approach is, as the bridge technology in order to compensate for that, is the plug-in hybrid. And I don't know, it's probably not well known here, but in Germany we built up a demo vehicle with our 3rd generation plug-in hybrid transmission. We increased the range to up to, I think it is about 60 to 70 miles pure electric driving, because we just wanted to make everyone aware, look, with plug-in hybrid technology, you can basically do your daily drive fully electric, but you don't have to have the range anxiety, and for your long weekend tours, for your summer vacation tours, you can use the same vehicle, but you don't rely on that charging infrastructure. That's not completely built out yet. So, and yes, I admit it's a plug-in hybrid, it's more expensive than a pure electric vehicle, but it's that transitional technology, and we received pretty positive returns on that.
So here's kind of a gearhead question for us that came in from Slido. How can racing and automotive sports change such that it can help drive development of future powertrain technology more applicable to passenger vehicles? And I think that probably relates to both EVs and ICE engines.
That's a great question, isn't it? I think it'd be interesting to see how that plays out in the future. But I have to say, I've always been cynical. Coming from a road engine background, I've always thinking, well, what are these guys in F1, Indy, and so forth actually doing to help what we're doing and what we're trying to achieve? But you do see that, and I've taken more of an interest in F1 technology of late, and the new rules with the boosted engines, the hybrid applications, the electric turbo systems are really interesting. And I think what appeals to me now is the 2021 F1 regulations, and even some of the talk of what organisations like IndyCar are doing, moving towards hybridisation. So I think the F1 rules are looking towards a very hybridised electric powertrain running e-fuels. And from our analysis in Mahler, that is very much the direction we see as the most cost-effective, sustainable solution for the future. Yes, of course, electrification is going to be huge and going to be a part of that, but we see e-fuels as another area of huge opportunity where we can use our existing infrastructure to develop the technologies we need for the future. So F1 technology will be, I think, leading the charge there, or at least I'd like it to be.
Carl, you were nodding?
Yeah, I agree with everything you said. I think traditionally the motorsport industry has been tasked with kind of a trickle down. I don't think it's been very effective in the past, but I think it's starting to move in that direction. I agree with you on the e-fuels piece, because it's, unless you're tying kind of the energy production with how we put that energy to use, you're missing the whole picture. So I have high hopes for that as well.
So we have had our race engineering division for a very long time. We were active in Formula One, not so much in engine, but with powertrain, clutches, and shock absorbers. And now we're active in Formula E. So currently this season we do not have an electric motor out there, but we had it in the past, and in the future, next season, we will have an electric motor out there in Formula E also. And this is coming back to your very first question. Yes, I think that's where we do the crazy stuff. Don't call them. And that's where we learn, that's where we can really go a little bit more extreme, and that's something where the experience, the knowledge can trickle down into later serious production.
Okay, well look, this has moved really fast. This has been a great conversation, but it looks like we've got a lot of questions I'd like to answer, but we're just out of time. So let's have a round of applause, please, for our panel.